Alright, this is the calculus 3 limit that I asked you guys on my Instagram. What's the limit as x, y approaching the origin? And that is x, y approaching 0, 0 of the function y over x. Is it 0 or 1 or infinity or the limit doesn't exist? Calculus 3, also known as multivariable calculus. We are dealing with multivariables in a limit. They are more confusing than the usual ones. But let's do the usual business first. Here, x, y are approaching 0, 0. So, can we just put 0 for the x? That will be on the bottom. And put 0 for the y. That will be on the top. Here we have 0 over 0. Can we just say the answer is just equal to 1? No, of course not. Because this is still indeterminate. Well, 0 over 0. Does that mean we can do L'Hopital's? No, because here we have y and here we have x. If you take the derivative on the top, you have to know with respect to what. They are different variables. That's not what L'Hopital's rule can do for us. So, what do we do in this situation though? L'Hopital's rule cannot help, so I'm devastating. No, don't worry. Let's just go back to calculus 1 and review a classic limit, and hopefully you can see some connections. Let's take a look at the limit as x approaching 0 of 1 over x. For this kind of limit, if you put 0 in here, you get 1 over 0, but you have to investigate this more, okay? X approaching 0, there's no plus or minus, so we will have to do both directions, right? We will have to check the limit as x approaching 0, let's say from the positive direction first. Well, this means if you put this right here, we get 1 over 0 plus. And in fact, we get to draw a conclusion. And the conclusion is positive infinity. Because 0 plus is like 0.001, right? Positive 1 divided by a very small number, you get a very big number. Just like that. On the other hand though, if you have the limit x approaching 0 from the other direction, here we get 1 over 0 minus, and this is like negative 0.0001. The result right here, we get negative infinity. So for this limit, we have an answer. For this limit, we have an answer. But this and that, they are not equal. They are not equal. So that we can come back here and say this limit does not exist. So this is how we can do it computationally. And now let's look at a picture to see what's going on. Right here, we are talking about the function 1 over x. So it looks like this and that. Somewhat like this. Alright, firstly though, when x is approaching 0 from the positive direction, that means you can use your right finger right here and you're just going towards 0 and you see that the curve goes straight up, right? That's how we get positive infinity. When x is approaching 0 from the negative direction, you see that you use your left hand right here. It goes down and we get negative infinity. As you can see, they are not going to the same point, so the limit does not exist. Alright, how can this help us out though? Here is the idea. We have a multivariable function. We have x, y. We are looking at the xy plane. Earlier, we just needed to look at the x-axis because it's on the x approaching 0. So we only have two directions, either from the right to left or from the left to right. But right here, if we have both x and y, and we're trying to get to the origin right here, how many ways can we get to the origin? Well, yes, we can still go like this and go like that, but we can also go straight up and down like this, or we can also go diagonal, or if you want to try like a Lamborghini, you can do like this, like that. That's okay too. So we have infinitely many ways to get to the origin. Oh, that's so bizarre. How in the world can we check infinitely many ways? don't worry. Same idea. If we can somehow come with two ways, right, two paths, and show that the limits don't agree along those paths, then we can say that this limit does not exist, just like this right here. It might be more difficult sometimes to show the limit does exist, but for this one, let's just go ahead and find two paths and help us out. Here, let me use the word along because we're going to go along the following path. We are trying to get to the origin, so maybe we can still be classic, go along the x-axis. Go along the x-axis. So go along the x-axis. And remember, the x-axis is just the equation y equals 0, right? Same thing. So use this, of course. Now, this is the limit as x, y approaching 0, 0 of y over x. But right now we are saying y is equal to 0, so you can put that right here, and you are just looking at the limit as x 0 approaching 0, 0. So y is fixed, it's always equal to 0. Then you put 0 into here over x, like this. And here's the key. The inside happens first. We have 0 divided by x. You must do that first. This situation is very different than that situation. It's not like you just put 0 right here and then say, that's indeterminate. No. You have to do 0 divided by x first, and then you end up with the limit as x 0 approaching 0, 0. This right here is just equal to 0. This happens first. Reduce that first. Okay? Now, x is approaching 0. That's all we have to look at because 0 is already fixed. X approaching 0 of 0. This right here, we get a legitimate answer 0. So this function, when we go along the x-axis, we end up with 0. Now we just have to pick another path and hopefully that path does not give us 0 for the answer. If two paths give you the same limit, that doesn't mean the limit is equal to that number, does it? Because we have infinitely many paths. So it might be trickier to figure out the actual limit sometimes. But anyway though, let's pick another limit, so another path. We chose the x-axis. So do we choose the y-axis this time though? We could, but the y-axis is the equation x equals 0. If you put 0 into this right away, that's a little bit bizarre. I don't like that personally. So let's do it diagonally. I want to go to 0 diagonally. So let's go ahead and choose this diagonal. Y equals x. In fact, you can pick any other slope right here for the line. They will still work. Okay. Go ahead, let's write that down one more time. This is the limit as x, y approaching 0, 0, and then here we have y over x. Under this condition, right, y is equal to x. I can replace the y to be x, or you can also replace the x to be y, up to you. Alright, so we have the limit. I will keep the x, and I'll change the y to x. And then this right here will still be approaching 0, 0. Now, because I changed the y to be x, on the top right here, I will have x on the top and then over x. If you wanted to say y here, then make sure you also have y here. Right? But anyway though, this right here, again, this has to happen first. X divided by x. And just like the good old days, when you have x approaching 0, x is not exactly 0. So reduce that, we get the limit as x approaching 0, 0, and then you just have 1. It doesn't matter what this is anymore, you just have 1 anyway, so the limit is just equal to 1. Guess what? We have successfully found two paths and they end up with different limits. So if you show this, you can go back to the original limit here and put down D, N, E. Whew. Just like that. Hey everyone, as a calculus teacher for over 10 years, I know how important it is for you to have access to quality resources to help you learn effectively. And that's why I would like to tell you about our sponsor today, Brilliant.work. Boolean is an online website with thousands of interactive lessons, and they are designed to make learning interactive and engaging. In particular, their calculus lessons are built around visual and physical intuition, which makes it easy for you to understand hard concepts such as instantaneous velocity, volume of revolution, and infinite series. What sets Boolean apart is their approach to problem solving. They don't just teach you how to memorize the formula, but instead, they will give you the tool that you need in order to solve the problem on your own. And this will help you develop a deep understanding of the subject and prepare you for success in math and science. So if you are looking for a fun way to learn calculus, then you definitely have to check out Boolean. Right now, they even offer you a 30-day free trial. Go ahead and use the link in the description, boolean.com/blackpenredpen, so that way you can get a 20% off discount. I want to thank Boolean for sponsoring this video, and thank you for checking them out. I wish Mr. L'Hopital or Bernoulli actually, or somebody could somehow invent a rule for multivariable 0/0 situation.